Artificial intelligence, or AI, is a technology that empowers machines and computers to successfully execute tasks traditionally requiring human intelligence. Essentially, AI helps systems learn from vast amounts of data, recognize crucial patterns within that data, and make informed decisions to solve complex problems. Its applications are already wide-ranging, serving sectors like healthcare, finance, e-commerce, and transportation, offering benefits such as personalized recommendations and enabling technologies like self-driving cars. The power of AI rests on several core concepts and technologies that allow machines to learn, reason, and make decisions autonomously. First, we have machine learning, often abbreviated as ML. ML is a subset of AI specifically focused on building systems that can learn from and base decisions on data. Critically, instead of being explicitly programmed for a task, machine learning models employ algorithms to identify patterns within data and improve their performance over time without direct human intervention. Next is generative AI. Unlike traditional AI, which typically analyzes and classifies data, generative AI is specifically designed to create new original content. This new output can take the form of text, images, music, or video. It leverages patterns learned from large data sets to generate new outputs rather than simply recognizing existing data. We also rely heavily on natural language processing, or NLP. NLP combines linguistics and computer science, allowing machines to understand and interact with human language in a way that feels natural. This technology enables features like language translation, sentiment analysis, and real-time conversation. It is the engine behind speech recognition systems such as Siri or Alexa that interpret what we say and respond accordingly. Finally, we encounter expert systems. These systems are built to simulate the decision-making ability of human experts. They utilize a set of predefined, if-then rules and knowledge often gathered from specialists in specific fields to make informed decisions. A classic example is a system that diagnoses a disease, similar to how a medical professional would proceed. They are valuable in areas where expert knowledge is important, but not always easily accessible. The working process of AI involves simulating intelligent behavior to perform tasks autonomously, helping machines learn, make decisions, and improve over time. The process starts with data collection. AI systems rely on large data sets, which can include images, text, or sensor readings. For example, training an AI to recognize cats requires collecting a data set of labeled cat images. This is followed by processing and learning. Algorithms are used to analyze the collected data and identify patterns. In the cat recognition example, the system learns to recognize key features like the cat's shape, ears, or whiskers, helping it understand the data. The third step is model training. The AI model is trained using the data, adjusting its internal settings to improve its predictions. With more data, the model becomes more accurate and better at recognizing new examples, even unseen images of cats. After training, the AI moves to decision-making. The system uses what it has learned to make decisions, such as determining whether a new image contains a cat based on the patterns it learned during training. The final step is feedback and improvement. The AI can improve through feedback, especially in methods like reinforcement learning. In this case, the AI receives rewards or penalties, refining its ability to make better decisions over time. AI can be categorized in two primary ways, based on its capabilities and based on its functionalities. Based on capabilities, we have three classifications. 1. Narrow AI or weak AI. This type is designed to perform only a specific task or a narrow set of tasks, such as voice assistants or recommendation systems. It is proficient in one area, like recognizing speech, but lacks general intelligence. 2. General AI or strong AI. This remains a theoretical concept where AI can perform any intellectual task that a human can do. It would show human-like reasoning and understanding across multiple domains. 3. Superintelligent AI. This is a hypothetical form of AI that would surpass human intelligence in all areas, capable of performing tasks more efficiently and effectively than humans. Based on functionalities, AI is classified into 4 types. 1. Reactive machines. These systems only react to specific tasks without storing past experiences and do not learn from previous actions. An example is a chess-playing AI that evaluates the current board and makes a move based solely on that position. 2. Limited memory. These AI systems can use past data to improve future decisions. Self-driving cars are a good illustration, using data from previous trips to navigate roads and avoid obstacles. 3. Theory of mind. This is a theoretical type of AI that would be able to understand emotions, beliefs, intentions, and other mental states. This would allow the AI to interact with humans in a more natural and empathetic manner. 4. Self-aware AI. This is the ultimate hypothetical form, possessing consciousness and self-awareness, enabling it to make decisions based on an understanding of its own existence. AI models are programs that learn from data and make predictions or decisions based on what they have learned, recognizing patterns similar to how humans learn from experience. One common approach is supervised learning models. The AI is trained on labeled data with clear input-output pairs, helping the system learn the relationship between them. The model is adjusted during training to reduce the difference between its predictions and the correct outputs. This is used for tasks like image classification, spam filtering, and medical diagnosis. Another approach is unsupervised learning models. These models work with unlabeled data and identify patterns, trends, or groupings without direct guidance. This method is valuable for exploring hidden structures in complex datasets, helping with tasks like anomaly detection, data clustering, and customer segmentation. Finally, reinforcement learning models. In this approach, the AI learns by interacting with an environment and receiving feedback in the form of rewards or penalties. Over time, the model optimizes its decision-making process to maximize positive outcomes. This is essential for robotics, gaming, and autonomous systems where actions lead to varying consequences. AI provides numerous benefits across sectors, improving productivity, decision-making, and user experience. Key advantages include efficiency and automation, which smooths workflows and reduces human errors, allowing humans to concentrate on more strategic tasks. It leads to improved decision-making by processing and analyzing large data sets to help individuals and businesses make informed, data-driven choices. AI also enables personalization by analyzing user preferences and customizing recommendations, enhancing user satisfaction as seen in platforms like Netflix and Amazon. Furthermore, AI offers 24/7 availability as it can operate continuously without rest, making it ideal for tasks like security monitoring and customer support. Lastly, its proficiency in data analysis and pattern recognition helps identify patterns difficult for humans to recognize, aiding in fraud detection and healthcare diagnostics. AI is active in numerous industries. In healthcare, AI assists in early diagnosis and treatment recommendations by analyzing medical data such as patient history and images. In retail, it personalizes shopping experiences and helps optimize inventory management. Customer service utilizes AI-powered chatbots to handle routine inquiries and provide 24/7 support. Manufacturing leverages AI to predict machine maintenance needs, prevent downtime, and enhance supply chain management. Finally, in finance, AI detects fraud, analyzes market data, automates risk management, and assists in personalized investment advice. Despite its vast advantages, AI faces significant challenges. 1. Data privacy and security. AI requires vast amounts of data. Raising concerns about privacy and ensuring sensitive information is secure. 2. Bias and fairness. AI systems can inherit biases from their training data, potentially leading to unfair or discriminatory outcomes that must be addressed. 3. Lack of transparency. Many AI models, especially deep learning, can act as black boxes, making it difficult to understand how they arrive at a decision, which is problematic in areas like law enforcement or healthcare. 4. Job displacement. As AI automates human tasks, concerns about job losses arise, requiring a focus on retraining workers for new roles. 5. Ethical concerns. The use of AI in sensitive areas like surveillance and autonomous weapons raises profound ethical questions, making it essential to find a balance between innovation and accountability. Artificial intelligence is fundamentally reshaping how machines interact with the world. From learning through supervised and unsupervised models to generating entirely new content via generative AI, its scope is continually expanding. Understanding the underlying concepts, the various types from narrow to superintelligent AI, and the ongoing ethical debates is essential as this technology continues its rapid advancement.